Hi, today we want to consider factoring quadratic expressions involving two variables. But before we start, let's preview what quadratic expression is all about. Now the question is, what is quadratic expression at all? Quadratic expression is an expression having the highest exponent of the variable involved being 2, or it's an expression which is of the form ax squared plus bx plus c, where the a, b, and the c belongs to real numbers or are all real numbers, and a is not equal to 0. In this case, we are saying that the a, b, and c, they are representing real numbers, so they can be 1, 2, 3, or some decimals. Yes, they can be that. But this a here shouldn't be 0. Why are we saying that? When the a term is equal to 0, or when the a is equal to 0, the whole of this term will not exist, because 0 times x squared will give us 0. So the whole of this term will not exist. Therefore, you are going to be left with the bx plus c, which is a linear expression. But that is not what we are interested in. We are considering quadratic expression. So the a can be any number apart from 0. So we can have an example like 2x squared plus 3x plus 1. This is quadratic expression. In this case, the variable involved is x. And what is the highest exponent of x? The highest exponent of x is 2. So that makes it what? Quadratic expression. Yes, we can have 3x squared plus 2. But this is also quadratic expression, because the highest exponent of the variable involved is 2. We can have x squared plus 4x. This is also quadratic expression. The variable involved is x, but the general one, the standard quadratic expression, involve all the three terms. That is the squared term, say 2x squared. We have the x term, so let's say 5x, and then the constant term, that is, let's say, minus 3. Okay, now we want to consider quadratic expression involving two variables, the standard one. Let's consider this. Now, quadratic expression involving two variables is of the form ax squared plus bxy plus cy squared, where the a, b, and then the c all belongs to real numbers, or are all real numbers. In this case, our a, b, and c, they are all real numbers. In this case, once again, a can be equal to 0. When a is equal to 0, this expression we are having here does not cease to be a quadratic expression. The most important thing is the highest exponent of the variable involved, in this case, is 2. And this is quadratic expression involving two variables. Once again, the two main variables that we are having here are x and y. If you look at the first term, we have x there. If you look at the last term, we have y there. They are all squared. And in the middle term, we have xy also there. This is quadratic expression involving two variables. Now, this type of quadratic expression involving two variables has distinct feature, which you have to get to know that. But before that, let's consider an example. So we can have an example to be x squared plus xy plus y squared. This is an example. We can have Another example to be equal to p squared plus 3pq plus 2q squared. This is also an example of quadratic expression involving two variables. We can have 2m squared minus 3mn plus n squared. Now, if you look at all these examples of quadratic expression involving two variables, the distinct feature about them is that if you take the first term, you realize that one of the variables will be there and it will be squared. So in this case, we have m, which is one of the variables, and it has been squared. You consider the third term also, and you have the other variable also there, having exponent 2. And you have the middle term having the product of the two main variables also there. That is the m, n. Always, the standard quadratic expression involving two variables is of this form, and you have to get to know that the first term you'll be having one of the terms having exponent 2. The third term also will be having one of the terms or the other variable having exponent 2, and then the middle term will be having the product of the two main variables also there. That is the nature of quadratic expression involving two variables. So get to know that they can make them up, but if you really want to factorize them, the standard one, this is how it's supposed to be. So we can have, let's say we have 2x squared plus 5xy plus 2y squared. So you realize that yes, we have x which is squared, we have y which is squared, and we have xy here. Now let's use this as an example. If we want to factorize this, how do we go about it? Now, for you to factorize expressions like this, first you need to consider the coefficients in all the terms. But what we are going to do, or what you have to do, is first consider the coefficient of the squared terms. So in this case, we are going to have the coefficient of x squared being equal to 2, the coefficient of y squared being equal to 2. They are all positive. So what we are going to do is you are going to multiply them. So in this case, you multiply 2 by 2, and that will give us 4. You find two numbers in pairs, which are factors of the 4, in which when you multiply, you get a 4. This 4 that we are having here. But when you add, you get the coefficient of the xy. That is positive 5. So we have two numbers, that is 2 times 2. Now 2 times 2 will give us 4, but when you add 2 plus 2, you are not going to get 5. So we can't use these two numbers, that is 2 and 2. We consider another set of numbers. So let's say 4 and then 1, because 4 times 1 will give us 4. But 4 plus 1 indeed is going to give us 5. So we are going to use these two numbers, that is the 4 and then the 1. In place of 4, we are having the 5. So we will be having 2x squared plus 4xy. The 5 was attached by xy. So these two numbers that you are bringing, you have to attach them by the same xy. So we have positive 4xy. The 1 is also positive. So plus 1xy, and then you bring the last term, that is your plus 2y squared. Now, as it stands like this, we have 4 terms. So you are going to take the first 2 terms, you factorize, and then you take the last 2 terms, and then you factorize. So in this case, when we take the first 2 terms, you ask yourself, what is the common factor there? The common factor there is 2x. So the 2x comes out, that is a common factor. You open your bracket. When the 2x comes out, when you factorize that one out, for the first term, you are going to be left with x. You bring your operation, that is the plus. Once again, when you factorize 2x out of the 4xy, you are going to be left with 2y. So you close your bracket. You move on to the last two terms, that is the xy plus the 2y squared. Once again, you look out for the common factor there. In this case, the common factor there is y. So the y comes out, you open your bracket, you are going to be left with x. Or because for the xy or 1xy, when you factorize y out, you are going to be left with x. So you bring your plus. Once again, 2y squared. When you factorize y out, you are going to be left with 2y. So you are going to have your x plus 2y being out, and then you have your 2x plus y, this one too, in another bracket. So you have your 2x plus y in another bracket. And this is the factorization of the expression 2x squared plus 5xy plus 2y squared. Let's consider another example. We have x squared plus 2xy plus y squared. Indeed, this is quadratic expression involving two variables, and it is in the form of the standard type. Now, how do we factorize this expression? Now, in this case, we are going to consider the coefficient of the x squared, that is 1, and then the coefficient of y squared, that is 1. We are going to multiply them. So 1 times 1, that is positive 1 times positive 1, is going to give us positive 1. So we look for two numbers in which when you multiply, you get 1. But when you add, you are going to get the coefficient of the xy, that is 2. And in this case, we know that 1 and 1 will be the perfect number, because 1 times 1 is going to give us 1. But this 1 plus 1 is going to give us 2. So we are going to use the 1 here and then this 1. Therefore, we are going to have x squared plus, so 1, we are having our xy. So xy plus this 1. So again, 1xy. We can decide not to bring the 1, but I want us to bring the 1 just to know that we are making good use of the number or the numbers here. That is why we are having the 1 there, but there's no need we bring in a 1. So we bring our last term, that is plus y squared. Now, having it in this form, the next thing you have to do is you take the first two terms, you factorize, you take the last two terms, you factorize. When we take these two terms, the common factor there is x. So the x comes out, we open our bracket, we are going to be left with x. Plus, once again, this xy. When you factorize the x out, you are going to be left with y. We close our bracket. We take the next two terms. In this case, the common factor there is y. So y comes out, you open your bracket, you are going to be left with x. Plus, y goes into y squared, that is y squared. When you factorize y out, you are going to be left with y. Okay, so in this case, we are going to have the 1 in the bracket, that is x plus y is common. Therefore, we are going to have that is x plus y in one bracket. And what we are having outside the bracket, that is this x and then this positive y, we put them in one bracket. So that is going to be, once again, x plus y. The x plus y, they are repeating, or the factors that we are having there, they are the same. So we can rewrite that as x plus y all squared. So that is how we can factorize this particular quadratic expression involving two variables. Okay, so I want you to try this question. Factorize 3m squared plus 10mn plus 8n squared. I want you to factorize this. Let me give you some seconds to try that. Or you can pause the video and solve this question. Okay, let's go through that. Now, as it stands like this, in this case, the two main variables involved are m and n. So if you look at the first term, yes, we have m, which is squared. And if you look at the third term, we have n, which is squared. So in this case, what we are going to do is we are going to consider their coefficients. So the coefficient of the m squared is 3. The coefficient of the n squared is positive 8. Therefore, we multiply the two numbers. Therefore, 3 times 8 is going to give us positive 24. So we have our 24 here. The next thing you do is you find two numbers which are factors in pairs of 24. That is two numbers in which when you multiply, you get 24, but when you add, you get a coefficient of the m n term, that is 10. So guess, find the numbers. You find the factors of 24. We have other factors, but which one is going to satisfy this condition? We have 2 times 12. That will give us 24. We have 4 times 6. We have 6 times 4 is the same. We have 3 times 8. Now, these pair of numbers, which are factors of 24, which one is going to work for this? That is, you multiply, you get 24, but when you add, you have to get 10. So the perfect pair of numbers is going to be the 4 and then the 6, or the 6 and 4. So in this case, let's use the 6 and 4, or the 4 and 6. Okay, so we are going to repeat the first term. We are going to have our 3m squared plus, we are using a 6, so 6mn plus. The reason why we are bringing plus is the number is positive. That is why we are bringing plus. So plus 6mn. Then we use this 4 again. So plus 4mn plus the last term there, that is the 8n squared. So we take the first two terms, we factorize. 3m squared plus 6mn. What is the common factor there? In this case, the common factor is 3m. So the 3m comes out, you open your bracket. When you factorize 3m from the 3m squared, you are going to be left with m. You bring the operation, that is the plus. Once again, 3m. When you factorize that from the 6mn, you are going to be left with 2n. So you close the bracket. Therefore, we are done with the first two terms. You move on to the next two terms, that is the 4mn plus 8n squared. You bring the operation, that is plus. Now, what is the common factor there? 4mn and then 8n squared. What is the common factor there? The common factor there in this case is 4n, because 4 will go into the 4mn. The same 4 will go into the 8n squared. Once again, the n will go into 4mn. The same n can go into 8n squared. So we are going to have our 4n. You open the bracket. When 4n goes into 4mn, you are going to be left with m. You bring the operation plus. Once again, 4n goes into 8n, 2n times. So now we are going to have our m plus 2n in one bracket, and then the factors which are outside the bracket, that is the 3m plus 4n, also in another bracket. So we have 3m plus 4n. All right, so this is how we can factorize this particular quadratic expression involving two variables, that is a 3m squared plus 10mn plus 8n squared. Let's consider another example. Okay, so let's try this. Once again, factorize 6a squared minus 7ab minus 3b squared. I want you to once again take a minute to solve this question. Pause this video and then solve this question. All right, I will be going through that, but I want you to pause this video, solve it, and then you compare it to my solution. Okay, so yes, we have this quadratic expression involving two unknowns. The first term, we have the a, which is one of the variables involved, having an exponent 2. If you look at the last term, we have the other variable, that is b, having an exponent of 2. And then the middle term, yes, we have the product of the two variables there, and that is a, b. So yes, this is the standard quadratic expression involving two variables. How do we factorize that? We go through the process. Take the coefficient of the squared terms. So in this case, the coefficient of the a squared is 6. The coefficient of the b squared is -3. So -3 times 6 is going to give us negative what? 18. Now this -18, we find two numbers in pairs, in which when we multiply, we get a -18, but when we add, we get a coefficient of the AB term, that is -7. Can you guess the two numbers? Because the number is -18, the two numbers which are factors of 18, one's supposed to be negative. So we can have 6 times 3 is 18, so we can negate 1. Now -6 times 3 will give you -18. But when you add, are you going to get -7? No. -6 plus 3 is going to give us -3. So these numbers are not going to work. What about -3 and 6? -3 times 6 will give us -18. But when you add, -3 plus 6 will give you +3. This is also not going to work. What about -9 and 2? Yes, -9 times 2 is going to give us -18. But -9 plus 2 will give us -7. So yes, this particular set of numbers is appropriate. Therefore, we are going to use them. So we are going to have our 6a squared. We repeat our first term, 6a squared. And then since we are using these two numbers, -9 and +2, so we are going to have -9. We are going to have our AB. Then this is +2. So plus 2, then we bring the AB. Minus the third term, and that is -3b squared. We take the first two terms, we factorize. We take the next two terms, and then we factorize. For the first two terms, the 6a squared minus 9ab. What is the common factor there? Can you guess the common factor? Yes, the common factor there is 3a. Because 3 can go into 6, 3 can go into 9. And we have a squared here, and we have a also here. So 3a will be the common factor. So in this case, we are going to have our 3a being outside the bracket. When we factor 3a from 6a squared, we are going to have 2a, because 3 goes into the 6, 2, and then a goes into the a squared, a. Minus, we come to the 9ab. 3 goes into the 9 how many times? We have 3, And then this a is going to cancel this a. That is when you factorize that one out, it's going to cancel that. So you are going to be left with b. So the 3a goes into the 9ab. We have 3b. All right, you close the bracket. You take the next two terms. We have 2ab minus 3b squared. What is the common factor there? Once again, can you guess? In this case, it is positive what? B. Because b is common. 2 and 3. We don't have any common number between them. But for this term, we have b here. For this term too, we have b there. So b is common. Therefore, b comes out. We open the bracket. We are going to be left with 2a minus, we have 3b. So since what we are having in the bracket, they are the same. 2a minus 3b, 2a minus 3b. So we are going to have 2a minus 3b. We close our bracket. The terms outside the bracket, we have 3a and then positive b. And that will be 3a plus b. So this is how we can factorize the quadratic expression 6a squared minus 7ab minus 3b squared. Okay, so I would like you to solve this last example, and that is 4p squared minus 3pq minus q squared. Okay, so this is where we are going to end today's lesson. If you have any question, feel free to ask by commenting. All right. Thanks for your time.